All right, this section here is on finding asymptotes for functions. So if you remember, a vertical asymptote is like this dotted line here. Okay, the graph could approach it and get very close to it, but does it ever touch a vertical asymptote? No. Okay, so it could approach it from the left and maybe go down to negative infinity, and approach it from the right and go to positive infinity. If it doesn't touch that line there, that's going to be a vertical asymptote. Okay, so definition of a vertical asymptote. If f of x, so if the y value approaches infinity or negative infinity, as x gets close to this value here, we're calling this c, but it could be any number, then there's a vertical asymptote for that graph there. Okay, so sometimes it's just said that the function is unbounded as x approaches c, meaning, there's no boundaries on it. It goes on forever. The type of limit in which f of x approaches infinity or negative infinity as x approaches c from the left or from the right is an infinite limit. So for this particular picture, as we're approaching c from the left, remember that little negative means we're approaching, whoops, from the left there. It tells me I'm using this and I'm not. And then if I'm approaching from the left, you see how it goes down to negative infinity. So that's saying that this one equals negative infinity. For this particular function, as I approach c from the right-hand side, it's going up to positive infinity. So we say it equals infinity. Okay, does that mean that this function exists or this limit exists? No. Okay, remember, an infinite limit does not exist. Okay, you're just telling why it doesn't exist. So in your homework, you can write, okay, this equals negative infinity, but realize it still does not exist, okay? So any questions on the first page here? So how to find an infinite limit? You can use your graphing calculator, and you can look at the graph kind of like we did here to see whether it's going to positive infinity or negative infinity. That's the easy way. A lot of times you don't have your calculator, so you have to actually select a number, and you're trying to find whether it's positive or negative. If it's an infinite limit, your answer should either be infinity or negative infinity. So if you know if it's positive, you know it's going to be positive infinity. If you know it's negative, it's going to be negative infinity. So that's what we focus on there. Okay, so we'll go ahead and try a couple of these, and I'll let you try a couple of them on your own, and we'll see how we do here. Okay, so let's just try this first one here. This is the limit of this function as x approaches, what does this mean? 2 from the left. So what's a number that's close to 2 that would be on the left side? Closer to 2. Closer to 2. Closer to 2. 1.999, right? Something like that. Okay. And couldn't I put a bunch of 9s after that if I wanted to? Okay, it's really close to 2 and it's coming from the left. So let's just think about what this is doing if I plug in a number that's really close to 2 from the left. The numerator is 1, right? Is the denominator positive or negative? Do you see how the denominator is going to be a very small negative number? So I'm going to write small negative number. Now, obviously we know it has to be either positive infinity or negative infinity, but think about a number over something infinitely small. Isn't it going to get infinitely large? A number over something super, 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 super small. Isn't it going to be really, really big? And the smaller I make this, the bigger it's going to get. So it's going to go to infinity, right? Now, is it positive or negative? Negative. So this is going to be negative infinity. Okay, and that comes up a lot, where you have a number on top, and then this is getting infinitely small. It would go to infinity. For this, we're just talking about infinite ones right now. Okay, so it's more the idea of it. Okay, so if I'm approaching 2 from the right, what would be a number for that? 2.01 or 2.000001, right? Okay, the numerator is 1. The denominator is what? Small and what? Positive. So what's this going to go to? Infinity. All right, let's try this one. Negative 3 from the left. What kind of number would that be? Negative 3.01. Think about a number line. If you're at negative 3 and on the left-hand side, wouldn't it be like negative 3 point something? So the numerator here is negative 1, and the denominator positive or negative? Negative, so a small negative number. So if I have negative 1 over a negative, it's going to become positive, and this is going to be infinity. Go ahead and try this one here. What number are we thinking about for this one? Negative 3 from the right would be negative what? 2.9s, right? So denominator positive or negative? Small positive number, right? So this is going to become what? Negative infinity. All right, let's look at the next one here. 2 from the left. What number could I put for that? 1.9, this, type of number here. So the numerator is going to be really close to what number? If I plug, 2 in, what do I get? It's about negative 4, right? It's going to be really close to negative 4. The denominator is going to be really small, what? Positive or negative? Negative. So overall, is this positive or negative? Positive. Okay, and it's a number over that really small, infinitely small number. So that makes me think this one's going to be negative infinity, but let's check it. This would be like 2.01. So again, the numerator is the same, so the numerator is about negative 4, and the denominator is a small positive. So that's going to give me negative infinity. So that did work out the way I thought. So questions on that? Okay, down at the bottom here. Finding vertical asymptotes. Okay, we have a vertical asymptote if and only if f of c is undefined. So the limit then does not exist, or goes to like infinity or negative infinity. So we're going to try these couple pieces here and find our vertical asymptotes. So if you want to write those examples. And the first thing you want to do is find where they're undefined. So where is this first one undefined when x is what? 0, and where else? How do we factor this? What comes out of both of those? X, and what's left? Okay, so where is it going to be undefined when x is 0 and 4, right? Because if I plug 4 in, wouldn't I get 0 in the denominator? Okay, so those are the two spots that I'm going to be checking here, okay? So what we're going to do is we're going to take the limit as x approaches 0 for this function. So I'm just going to put f of x. Okay, as we approach 0, think about approaching 0 from, the right and the left. Maybe I'll write this first one out a little bit more. The other ones I'm not going to write out as much. So I've got x plus 4 in the numerator, right? And in the denominator, we said this was x times x minus 4, or you could leave it like that if you want to. I just kind of like the factored form. Let's say I plug a 0 from the right. The numerator is going to be about 4, isn't it? The denominator, if I plug 0 from the right, this is slightly positive, and this is negative. And isn't it going to be a really small number if this is really, really close to 0? Okay, so I have 4 over something really small negative, so this is going to go to what? Negative infinity. Make sense? Now, is that defined? No. So if the limit does not exist, we're going to say, here, does not exist. Okay, if I approach 0 from the left, it's going to do pretty much the same thing, right? Except for it's going to be going to positive infinity. So if we know that the limit does not exist, then we know this is a vertical asymptote. Okay, so I'm going to say, therefore, vertical asymptote, which I just say VA a lot of times, at x equals what? 0. Okay, so this is one of them. Okay, then you do the same idea for x equals 4. So we take the limit as x approaches 4 of our f of x. And you can approach it from the right or the left. You can do both. Okay, as I approach 4, the numerator is 8. The denominator, this, if I approach from, let's say, the right, isn't this really small? Is it positive or negative? Positive, and this would be positive. So I would end up with infinity if I approach from the right. What would happen if I approach from the left? It'd be negative infinity, right? So does this exist? No. So it does not exist. So what do I know? It's a vertical asymptote, right? So there's a vertical asymptote at x equals 4. Okay, so these are my vertical asymptotes. If this went to like a number, it wouldn't be a vertical asymptote. Okay, because there's actually a value then for that spot. Okay, so let's try this one here. See if this clears up anything. Okay, where is this one undefined? So how would I factor the denominator? It's difference of squares, so what would it be? X plus 3, x minus 3. So it's undefined where? So it's undefined at x equals 3. So these are the two spots that I'm thinking there might be vertical asymptotes. And x equals negative 3. So I'm going to take the limit as x approaches 3. Now I'm going to factor this. So the denominator is x plus 3, x minus 3. How would I factor the numerator? What adds to here and multiplies to here? 3 and 1, right? And the denominator was x plus 3, x minus 3. What happens to the x plus 3's? They cancel, right? So now do you see how if I plug 3 in, the denominator is still 0, isn't it? So if I approach from the right or left, it's going to go to either negative infinity or positive infinity. So does this exist? This one's a does not exist, right? So if this does not exist, I know there's a vertical asymptote at what? X equals 3. Now we're going to do the same thing with negative 3. Now if I factor this and the x plus 3's cancel, and I do a direct substitution where I just plug negative 3 in, don't I actually get a value? So go ahead and plug negative 3 in. What do I get in the numerator? Negative 2. What do I get in the denominator? Negative 6. So doesn't this equal 1/3? So is there a vertical asymptote here? No. That would be a hole in the graph. Okay, it's undefined at that spot, so there's actually a hole in the graph at that spot. Yep, try a direct substitution. If the denominator is 0, and you can, factor that 0 out like here, you're okay. But otherwise, it's going to go to infinity or negative infinity. Yeah, like this here, this canceled. If you do a direct substitution, it gives you a value. It does not have a vertical asymptote there. Okay, any other questions on this?